Good afternoon. Last session. And when I think Joe just said doors are closing, I was tempted to say, cabin crew, cross-check, and doors close and cross-check, please. Arm slides. So I hope we don't need it. We needed it this morning, so not the slides, obviously. Those slides, that is. All right. You can see the list of certifications at the bottom. I won't go through all of them. Some of them are security related. Some others are privacy related. There's two still missing. One is risk management related and another one in privacy. And I'll probably cut it quits doing exams and doing anything more. Okay, GDPR will certainly feature in today. And as most of you might know, it's just 9 days until enforcement starts with GDPR, and we'll really have to see what comes out of that. It's unknown for me, it's unknown for you guys as well. But there is some stuff in GDPR which really goes into security and also privacy by design and default. So we will come around to that in the next 40 minutes or so. Oh yeah, if you hear something speaking in the background through the microphone, it's just my laptop blaring out, speaking out the slide titles. If there's anything you want to ask during the session, just put your hand up, and I think Joe will spot it. I won't. So I'm completely oblivious to that. So I've mentioned GDPR a couple of times. Who has never heard of GDPR? And I don't expect any hands coming up now. No? Okay, that's good. I won't ask you what it stands for. I will tell you that in a minute. So in the description of the talk, I mentioned briefly the OWASP 10. Anyone that hasn't heard about this? A couple of hands. So OWASP is like the open web application security platform or project, I think it is. And they do a list of vulnerabilities, and they have done that for the last about 10 years. We'll still have to see what the new one, 2080, will bring. Then we'll go for GDPR, and that will be, well, maybe slightly the boring bit, because you have to go through some of the legal jargon in here. I'm especially putting you guys through this, because I really want you to know and understand what's going on here. I won't put you through all of it. The whole legal text will be 99 pages, so I probably can't fit it in 45 minutes. But I picked out the most important bits. I have about 6 recent articles where security and/or privacy absolutely went horribly wrong. And I'll talk you slightly through why I think that's the case and what happened actually. I nicked most of them from the register, by the way. I think there's one from another side. Okay. So, OWASP 10, and if you look at the 2007 list, you will see cross-site scripting there at the absolute top. And on the 2017 list, it's still there. It's further down. And now, the only question I have with this, and I probably need to ask this at the OWASP team, they have redesigned how they build up this list, which risks there are, which definitions there are. But even though they changed it, it's still there. And I'm quite amazed why it's still there. The same goes for input validation or validation errors. It's second in 2007. It's on the top now. And, well, though the names changed through those 10 years and the definitions changed, you can still link some of them to the list from 10 years ago. And so I know developers have a problem with security, and security people have a problem with developers. And I have done some coding myself when I was still in university, which is over 10 years ago. So I probably can still do it. Probably be a bit rusty. I can still read code, which comes in handy if you read some penetration test reports or some code review reports. And I even had sometimes to describe what the penetration tester actually found and what the security issue was. In one case, actually, with one client, we had to tell the developers, well, you're needing to do a code review on production. Why the hell are you including all your development code as well? It's giving a weird picture. And they had to do the scans for some government connections. So cross-site scripting, yeah, it's still on place 8. It's probably related to input validation. Make sure those characters can't come into your backend. And no coding and checking this in your front end, so the website, it's not enough. You really have to do this on the server itself. When I was still at university, one company wrote an online voting system for the Students' Council. There wasn't JavaScript in that. At that time, I was using a browser which didn't support JavaScript very well. And so I couldn't submit my vote. What I did is download the page, remove the JavaScript, wrote my own submit button, and submitted it that way. Completely circumvented their entire checking mechanisms. When I told them that on the results day, they were absolutely horrified. So, what's personal data? Don't read the entire description on the top. The 4 points at the bottom are the most important ones. So any information related to an identified or identifiable natural person. So any information could be an IP address, could be even these slides. Are these slides personal information? No. Is an IP address personal information? That depends. Related to, obviously clear. Identified or identifiable, that's always a tricky one. So if I write down my email address, it's obviously is personal information when my name is in there, because it directly relates to me. I can directly be identified from it. Now, if it's an IP address, they might have to call my ISP or mobile provider to find out who used that IP address at that particular time. That's identifiable. So you can use third-party information to still identify me. A natural person means any living person. So when you die, you lose your privacy. Yeah? So, and before you're born as well, which is always an interesting one. To give you an example, one of the sponsors downstairs, the one where you can sign in for bubbly bits, or champagne for that matter, you need to put in your company information, name, phone number, email address. You might or might not win. Below that, they say, well, we're going to contact you for marketing information as well. Okay, one purpose is the drawing. Fine, you need some information for that. The marketing purpose is not related to that. It's not even closely related to that. There's some other rules for that as well. I think what they think is that by putting in company information, they think it's not personal information. Well, that's absolutely incorrect, or for some of it at least. So if you, for instance, have an email address, joe@theregister.co.uk, it's clearly personal information because, well, we know who Joe is. At least most of us do. Same goes for my email address. For my company, it's a bit different because of the company form. But info@shamrockinfosec.com is generally not directly personal information. A phone number, a mobile phone number, even if it's your business phone number, is personal information. Certainly if they have a name with it, that's identified. If they only have the phone number, it might be identifiable because your company knows who you are and whose phone number they gave to which person. So it's always an interesting thing to talk with marketing people on this kind of effect.
Slide 5, privacy by design.
Okay, I've highlighted a couple of points on this one to make it easier for you guys. And the reason why I've done this is because this is a big load of text. It's reasonably readable. So what they will actually say here is that you have to look at the state of art and cost of technology, which means you don't do it only once. Make sure you keep re-evaluating this. You have to know what personal data you have. Well, we just talked about what personal data is. You have to know what you're processing it for, what you're needing it for. And you have to make sure that in all your processes, it's handled correctly. That means in your code. That means in your handling processes. That also means you have a purpose why you got it. See, for instance, for that drawing, they got your data to, well, contact you if you won. Now, the last couple of years, there's been an enormous discussion going on about using production data in testing. Is that a related purpose? Did I give you my contact information to test your systems? Well, some of the data protection agencies, I know at least the Dutch ones, has no. So what would you have to do in testing with personal data? One of the other things, specifically for developers doing development, testing, maintaining productions, how do you keep that separate? How do you make sure personal data from your clients doesn't end up in a testing or development environment, which most of the times is less secure? You might get into trouble here. So just like security, and for those who have been at the Make Shift Happen presentations earlier, starting with secure coding, this is one of the other things you need to do. This is part of GDPR. If you don't do this and they find you out you have a massive data breach, a lot of trouble, this is actually finable for the company you're working for. It's not the 20 million and 4%, it's half of it. And it's a maximum fine, obviously. But still might be a bit of a bummer if something would happen. And I think this morning they were also talking about accountability. So you developers having accountability for something going wrong in production. Well, this is part of it.
Slide 6, private.
Slightly shorter one. By default, make sure you only have the personal data you really need. So if you need to contact me for something, you only need my name and email address, only collect my name and email address. You can collect my phone number as well, but if you're not going to use it, why have it? Minimalization. The less is better. Obviously goes with code as well. And for the agile people with documentation even more, I believe.
Slide 7, security requirements.
And so some of these requirements have been part of data protection law for the last 20 years. Now they're finable. Now everybody's jumping through hoops and panicking. Again, as I said before, sometimes baffles me why. I can understand why companies don't do this. Costs money. Well, this might cost you more. Again, here you will see state of the art, cost of implementation, and the standard security principles of availability, confidentiality, and integrity. Interestingly, the legal people in Europe has put an extra term with this, and that's resilience. Nobody knows what they mean with it. We'll have to find out. And yes, even people in the UK, because this comes into force before Brexit. And even if Brexit actually happens, we'll have to see with that one. So, any questions so far? No? Good.
Slide 8. The Twitter screw up.
Who has gotten a message from Twitter in the last 2 weeks? Sorry, we screwed up. We had a bug. We need to change you need to change your password, and all is fine. Probably everyone who uses Twitter, eh? Yeah. Me too. Haven't done it yet. Got two-factor authentication on it, so probably be okay. On the other hand, you're using a cryptographic library. Fine. Why are passwords even in log files in the first place? Is this a development testing hook that was left there? Well, we don't know. The interesting bit here is that it wasn't only Twitter who got screwed with this one. So it might even be a bug in the crypt library. It was GitHub as well, which is further down the article. If you look it up on the register, you will see that they got screwed with this one as well. It might have been an internal file, but if you really want to keep things secure, crypt it or hash it immediately, never store it anywhere else. It's basic security. And we'll have to see if that really was left over from a development hook. And we'll see an example of probably a leftover development hook in a couple of slides as well. I would not directly call this a bug. It's probably something left where it shouldn't belong.
Slide 9. Intel kernel memory leak.
Oh yeah. So this one has been in silicon from Intel for a decade. And now all software developers, specifically in operating systems, need to fix this one in their software. Because, well, you can't replace two decades of silicon. Intel might like you to do so if they can sell you new chips. It's probably not going to happen. What actually happened here is that every process has a bit of kernel space, kernel data in their memory tables, or had actually, because it's changed now. The process didn't know, didn't see it, but it's still there, making life easier. I would call that security by obscurity, specifically with this bug in mind. Was this a screw up? I don't know. Was there secure coding involved in designing the code that was used for these chips? Probably not.
Slide 10. Car hacking by app.
Okay. So you have your brand new Hyundai car. You connect to it with an app. And then Hyundai decides to send all your data back to their servers unencrypted. And the bits that were encrypted with such a default key that you could easily extract it from the software. One thing that a lot of times goes wrong is cryptographic key management. And I think one of the other talks already mentioned default passwords, hard-coded passwords. I think have seen a lot of those in the Internet of Things, or the Internet of Things, I would call it. This is what we might call security and privacy by design. You know, you need to transfer data from a device to another device over a inherently insecure network, aka the Internet. This should have been in place. Okay, they did it with an update, fair enough. It would have saved them so much work if they've done it in the first place. And that's your basic mindset, your basic thinking you need to have to make sure that these things don't go wrong. It's not that difficult, even secure coding, it's not that difficult. You need to have the right training, Yes. And you need to have the right practice, yes. It's not that difficult.
Slide 11. Mac OS root bug.
Okay, this is the other one that's probably left by a developer. Enter root, go to the password field, press enter, then press login. Interestingly enough, within a week of this one being fixed, they had another one in the preference panes in macOS as well. So there are certain preference panes in macOS system preferences. That's your control center, I think, under Windows, which are locked, and you need to enter a username and password to make sure you can do any changes. Or if you're logged in under a non-administrator account, you need to log in with an administrator account to be able to do any of the changes at all. One of the preference panes wasn't a high security one, but you could sort of screw around with this kind of entering fake identification and go through it as well. Now, I can imagine if you're testing a system and you need to make sure stuff works, that you put in the development hook saying, like, I put in security, or I put in root in this case. Root like is your super user, which would be called administrator under Windows. It's also called root under Linux, by the way. And put in a blank password, because setting a password all the time is difficult and it's not handy. Oh, and the root user is disabled by default under macOS. Yeah, so I can imagine that code's there. What the hell is it doing in production? Why wasn't it taken out? Why wasn't it spotted? They fixed it quickly enough. It's just a bit of a problem, isn't it? You really don't want these kind of development code blocks in your production environment. Some old Nokia phones had that problem as well. If you scanned them over Bluetooth, you found a surface not being broadcasted, but you could connect to it and take over the entire phone. Very nice for developing. Should never have made it to production. And I don't remember which phones it was, and it was about 15 years ago. So, and since Nokia doesn't make that much of phones anymore, it's probably not in there.
Slide 12. iOS HomeKit security.
Log into somebody's phone, take over their entire house. Lights, cameras, no, not action, logs. I think Apple had a bit of a rough time at late last year. Recently I spotted another one, which I haven't included, where you could take over a Mac through error handling in their development package. So put a wrong app in, and you could take over. That one is fixed as well, by the way, now. The only thing Apple does, which is in this respect good, they very quickly realized these bugs are there when they were notified, fixed them, and sort of inconvenienced the users by disabling remote access for third-party users. So the main user could still access it, but all your guests couldn't. Bit of a bummer for a week, but well, we can live through that. It's at least better than most IoT stuff, which is not secured at all.
Slide 13. SmartBox fail-safe.
This is another one, which is, if you want to do over-the-air software updates, no problem. But A, make sure when you're sending them out, they're the right ones. And B, on the device that's receiving them, make sure that software update is for the device it's sent to. So what happened here is they send out a software update to their smart locks, which was meant for another series of smart locks. So the distribution process went wrong here. And apparently there was no check on the local device verifying that the software update it received was actually meant for it at all. Which might be a nice way to attack these devices as well, since it apparently is not verifying if that software update is actually coming from the valid sender and is a valid one for me as smart lock device. So it bricked them. Since those ones are mostly used for Airbnb host, and the regular key did still work, only the PIN code didn't work anymore. And you could get a replacement in a week or 2 weeks' time. Slightly inconvenient, but it shouldn't be there. And again, this is like thinking your process through. And now, is DevOps compounding this problem? Maybe. And the only reason why it might compound this problem is that there's more pressure on you developers to do things faster, quicker, more efficient. And every time you deliver something, it must be a minimum valuable product, and it must actually do something. And if you do security testing afterwards, you still need to fix it. But then again, the new release comes along, your new backlog items come along, your new development cycle comes along, and those security bugs will not get fixed. Why not? Because you're simply not getting the time for it. So again, security by design, secure coding by start, absolutely essential to make this work. It will save you guys a lot of time in the long run. For the simple reason, those security bugs will still there, but there will be less because you have taken care of most of the stuff that can go wrong beforehand.
Slide 14, helpful guides.
Okay, there's 2 helpful guides that have been brought out. One is by the Information Commissioner's Office here in the UK, that's the Data Protection Agency here. The other one, which is a better one, at least a more detailed one, is from the Norwegian Data Protection Agency. I have the URLs on here. If you look for privacy by design and default, and type, for instance, in Norwegian Data Protection Agency, you will easily find it. So that will be a good read to start to see what's going on there.
Slide 15, contact details.
So if you want to contact me, that's my company name up there, URL, email address. And yes, that email address is personal data, as we just discussed. But I'm giving it to you out of my own free will, so there's no problem there. And my Twitter handle, I'm on LinkedIn as well. If you really want to link, that's fine. Just note in a message with that you've been to my talk at COL 2018, so I know where the link is coming from. And for those who really want to dive deep into GDPR, we're running a GDPR certification course this weekend here in London. And there's more details on the website. The only caveat is you need to decide quickly because we need to close registration today. If for any chance you can't make that and you still want to participate, see me tomorrow and we'll work something out.